Hello, welcome to this video which is going to be a tutorial in JavaScript where we're going to make something like this, a simple version of this demo or simulation where we can do what I just did there, where we can move objects, sprites, NPCs on screen using either touch interaction or mouse interaction. Right. In this demo, which is I've called Blinkies with Matter.js, I'm using a library called Matter.js. What we're going to do today is not using Matter.js, but just the P5 library on its own. So just a word very quickly about how to set up. So if you wanted to code along, or or you know make your own game or simulation, anything at all, using P5, you can get started quickly. So you could download the P5 library online. If you know what that means, then you can get yourself set up fairly quickly. Or if you're not sure what that means, you could come onto this site, which is CodePen. Here's the main page, and then you could try and find me on there if you like. Red Hen Dev is the username I'm using, or just put in P5, and that will find sketches or pens, I think they call them on here, that use the P5 library. And what you could do is click on any of these, and it's all open source. So then you could delete the programming there and start afresh. It won't change what anyone else has done on here. Essentially, what it's doing is copying to your browser a version. So whatever you do there won't destroy anyone else's work. So I've got my emoji pong demo has come up here, and some other things. So here's a P5 template, actually, another one that I've made. So you can click on it, and then it'll take you to here, a web page where you can code the JavaScript. I'm just going to maximize this window, so you can code along, and everything should work. So we could change the background color to maybe kind of grey. There we go. So it's amazing. You can code, and then CodePen updates things live. So that's how to get started. Or you could look at one of my previous tutorials, and I think I've got some links there to Daniel Schiffman, Coding Train. He has wonderfully informative and much clearer explanations of how to get started. Also how to use the JavaScript library with a dedicated editor like Sublime or Atom, or like brackets, which is what I'm going to use today. So I've just got a brackets editor open with a JavaScript file already linked to the JavaScript, to the P5 library. I've just realized I haven't linked the correct script here. Let's just do this. So I want mouse, that one. There we go. So what I'm just doing here is just setting up my brackets browser, brackets editor with the P5 library to run a local server. So let's get started. What do I want to aim to do? First of all, we want to make some kind of creature. I'd love to make this little egg, and then when we move the mouse over him and drag, and then we can move him around gently, nice and gently. Or if we're touching the screen, wherever we're touching, as long as it's on his body, then it's moving him around. That's what we'll aim to do. So back in brackets, let's get started. So using P5, that means I can use the setup function. So this is where the program will start. And what you need to do then is create a canvas, and that takes two parameters, which tells JavaScript and P5 how big you want your playground to be. So let's have it 400 pixels across, 400 down, and then the color. And this P5 function, background, takes 3 parameters, red, green and blue, RGB, maximum 255. So the higher that number, the brighter it's going to be. So I've been using a lot of pink recently, so let's go for green. Let's go for 0, therefore, 202, and a little bit of blue, 42. There we go. And in the brackets editor, you press this little live button there, and it creates a local server for you, and we're working. Okay, there we go. Mouse interaction 1.0. So we want something for the mouse to interact with, so we need to draw, where's he gone? Our little buddy here. It looks like a ghost egg. A ghost egg. I've never seen a ghost egg. Let's say it's a ghost egg. I've lost the brackets editor. So we want to create an object in terms of an object-orientated object. So to do that in JavaScript, you essentially make a function, and then you give that function the name of the object that you want to make. So I want to make a ghost egg, please. Function ghost egg. And so that this isn't behaving like an ordinary JavaScript function, we now use the this keyword. So when we're dealing with objects, the this keyword basically points that value or variable, I suppose, to this particular object. So we can make loads of objects, and when we use this, it always refers to that particular object, and that will become clear as we go on. Right now we haven't got anything working on the screen, we haven't got different objects, so it's a bit abstract at the moment, but don't worry. So we want to give it a position, and an X and a Y. I gave this tutorial a go. I recorded a video, I might upload it, where loads of things went wrong, which is quite nice because it shows you the process of debugging, and it might indicate some problems that you might have. So I might upload that, or I might accidentally do those bugs again. But I didn't use vectors, and it did work, but it was a little... It did work. Let's use them again. Anyway, this X equals 0. And we need this Y equals 0. Right, so that's its X and its Y location on the screen. X across, Y up and down. And what's very important is you must give it a value to begin with, else you might have a few bugs happening. JavaScript might not know what kind of what kind of variable you're using. Are you using a boolean, a true, false, a string? It might leave it undefined. So you might get some errors. So good practice. Plug in a default value with the right data type. So I'm using like floating points, I think is the default for numbers here. So this XY, we've got location. So now we need a speed. We want to move it. So we want this speed X equals 0. So we don't get any problems. This speed Y equals 0. And now we want acceleration, or let's call it force. A force on the X, and then and then let's just put some spaces in here so I can lift my text a bit higher. So this force equals X. This force equals X. This force X equals 0. This force Y equals 0. And oh, we haven't given him a size, or she. We haven't given her or them a size. And it kind of looks like a circly thing, so let's call that size radius. So radius would mean from its center position, its X and Y, to its edge, not the whole diameter, not the whole way across. So keep that in mind. So this radius equals, I don't know, size 64. Size 64. Now, we want the egg to appear. So, as well as giving it attributes, we can give it draw the egg. We can give it a function. And so instead of putting a value in here, because now draw egg would just be like the other member variables, it would just be a variable. We want it to be a function, so we say this dot draw egg equals a function, and then we write our function. So then we'd have a complete object. We'd have attributes, variables, and we'd have functionality. We'd have a member function, right? But there's two ways to do that. You could create the function here, which would create a draw egg function for every single ghost egg or whatever object you make but we really only want one draw egg function that all ghost egg objects could use. So JavaScript uses prototyping, which I won't explain. I don't understand it. I don't understand it anyway. But let's put that function down here just to show you the difference. So actually what we'll do, we'll draw the egg here, but then I'll do the physics of the egg down here. So to start this prototypical function, what we're going to call it is the physics of the egg. So we want it to do the physics, do physics, and that equals a function as well. So that's the syntax for a function now that won't be created for every single ghost egg that we made, but is a function that every instance of a ghost egg can use. So it works in exactly the same way, but will be tidier. It will be tidier. But I could have made that up here, and I could make the draw egg down there. Okay? For us, it would work in exactly the same way. Key difference, this is tidier, possibly more efficient if we're doing something very, very fancy. So let's draw our egg first. So we want an ellipse. This is a P5 function. It won't work in native JavaScript, I believe. So ellipse, and then it takes 4 parameters. So there's 4, in case you didn't know, 4 fingers. We need an X and Y, and then we need how big the egg is going to be, or the object is going to be. So this is where you use the this keyword again, because if we just put X, it doesn't know what X you're talking about. Maybe you made a global variable. So you want this particular egg's X. And if we had 2 eggs, this egg X would mean that egg's this X, if that makes sense. So this X, this Y. So that's the center of our ellipse. And then we want it how big across. We want the radius. And then we want, like our drawing, let's refer to our blueprints. We want this to be a bit bigger, just a tiny bit longer. So we could write that in here. We could write something like this, radius times something like 1.2. Excuse me. However, I'm just thinking, here's some basic optimization. You're doing this calculation, or rather, you're not. You're just sitting at home, living your life. But JavaScript would have to, your computer would have to do that calculation every time the egg is drawn. So what we could do, which would slow down your animation, your program, what you could do is when you first make a ghost egg, you could then say this radius y equals this radius times 1.2. So we're doing the same calculation, but we're just doing that calculation once when the egg is first created, because this function will run when you make a ghost egg, and then it won't run again until you make another egg. Our draw egg function will run every time you draw an egg. So now we can just take out this radius times 1.2 and just refer to with that variable. So now it won't have to calculate every single loop. So that's something to keep in mind for optimization. Let's write a comment for optimization. Smiley face. We've done well. We've optimized our code ahead of time. We've made it run faster. So we've drawn our egg. Let's make an egg and see if he appears, because if I run the program, we shouldn't have an egg. I'll be really scared. Particularly if it's a ghost egg appeared. So we've got no egg because we haven't created an egg. We haven't told the program to even draw that egg. So let's have a global variable. Let's call it test egg. That's a bit impersonal. Let's give it a name. Susie jumps to mind. I don't know why. Variable Susie. Now that variable might be a number. It could be anything, but we don't want it to be a number. We want it to be a ghost egg. We want it to be a ghost egg. There we go. Now, that won't work. I've not done things quite right. The syntax is not right. I've also misspelled Susie. So let's change it to Suze. I like Suze now. That sounds really cute. Suze. We need to say Suze equals new. New is a keyword that JavaScript needs, so it knows it's dealing with an object. This is an OOP object, an object-oriented programming object, a proper object. So if you use new, JavaScript knows to look for an object that you've made. Also, remember that to make an object, you basically write a function. So you need parameters, or parentheses in which you put parameters. Now the syntax is right. Now we should have a Suze. And can we draw a Suze? So I think we've got draw egg ready. Draw egg. Will this work? Here we go. Yes, we've got a Suze. Now Suze has been drawn top left because her x and y is 0. So it'd be cool to create Suze randomly somewhere on the screen. So let's make use of these parentheses. So an object can receive parentheses. So we could take in an x and a y. I'm just using this underscore to help me remember that these variables are parameters. You could just leave it x and y. It would work fine. So instead of 0, 0, we're going to say create Suze at x and y. So when we create Suze now, we want to put in a value. So we could put her in the middle of the screen, width divided by 2, height divided by 2. Height and width are P5 keywords or variables that it's used and reserved, and it will just store whatever size canvas you've made. So we could change this number. And width and height would accordingly change. And so we'll now have, oh, I want to crack my neck. We should now have Suze in the middle of the screen, which we haven't got. Suze has now disappeared. Something's gone wrong. Suze, where are you? Oh, I put those parameters in the wrong function there. There we go. Suze. Suze, are you there? Suze. Yes, there she is. Now, also notice P5 does some things automatically. The outline of the egg is black. Also, it's got an outline, and it's got a white color. So automatically lines, or strokes, P5 calls them, will be black, and there'll be that thickness, and you'll get a white fill color. So in render, we can play around with this. So we're going to keep fill to white. So that's 255, 255, 255. By the way, P5 allows you just to put one number in, and then it will assume that the other green and blue parameters will be 255 as well, or whatever number you put in. So we'll just put that there. And stroke color will keep black, which is just 0, 0, 0. But we want the stroke weight, so that's the thickness, to be a bit more, maybe 3, because then it might look a bit more like my design. Let's try and keep close to the design. What happens if we put the mouth down there? Kind of introduces, this is, sorry, going off topic. It's like a design discussion. We've added maybe intelligence, maybe a bit of age to our ghost egg. Interesting what you can do. We could also put like a bit more weight here. Now it looks like it's opened its little mouth, cheep, 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 like that. So maybe we could change that in our program and have him speaking, or she speaking. Right. So we've added some stroke weight. So now Suze should look a bit better. Oh yes, very nice. So we've got Suze. We need to give Suze some eyes. Let's do that quick. Let's just give her a mouth. I want to keep this video as short as possible for you. So this dot x, this dot y, this dot x, this dot y. So to draw a line, the first two parameters tell where the line to begin, and then the second two parameters where to end. So at the moment we're just drawing a point because and that will be in the center of Suze. So we're doing her mouth. So we want the line to go minus maybe 1 plus 1. So that's a cross. And then maybe we could just go minus 1 in terms of the height. We want to lift that mouth up a little bit. Let's just have a look at this. Oh, the stroke weight will be the same. There we go. So we've got like a little mouth. Oh, let's put eyes on. Let's quickly put eyes. Oh, I missed a semicolon there, but it still worked. So let's draw our eyes down here. So we do want these eyes to maybe be black. So we've got to change the fill, because the fill here was white, and we would draw white eyes. Right. So we want ellipse again. Let's just copy this. So we want the ellipse again, and we don't want the radii to be different here because we want a circle. So make sure that the second pair of parameters are the same number, and our ellipse will be the same dimensions, x and y. So the position first. Actually, let's look at the size. So we'll have radius divided by 8 divided by 8. Again, I would have to do that now calculation, or rather the computer would have to do the calculation every time we draw the egg. So maybe let's just give it, what we draw in eye size. Let's make a member variable up here. This dot eye size equals this dot radius divided by 8. And then we can just plug in that parameter here. This eye size. Fantastic. Fantastic. Fantastic programming here. Very good. Right, eye size, eye size. There we go. So now we're just drawing them. Where are we drawing? And I'm talking about 2 eyes. I've only done 1 ellipse. So we need 2 of them. And we're just drawing them at x and y. So that's the center of our ghost egg object, our Suze. So we need to draw them slightly above. So our mouth is just 1 above, so maybe 3. So minus 3 would move up the screen, plus would go down. And our left eye has got to be towards the left of the screen, so minus, I don't know, minus 3 again, and plus 3. This is going to look terrible, and I don't think the mouth is going to show. So let's plus the mouth by 3, just to move the mouth away from the eyes. And let's comment our code so that if we come back to this in the future, we'll know what all of this means. So this is the mouth. This up here is the main body, smiley face. These are the eyes. Hopefully, hi. These are the eyes. Hi. There we go. Run it. I'm very excited to see our ghost egg called Suze. There we go. It kind of looks like a Minecraft thing, like a villager or something with a long nose. Let's just lift those eyes up and apart. I'm tempted just to leave it. Up. So -3, -7, +5. Now I'm kind of hard coding these numbers again. Again, I should do something a bit more optimized, a bit more efficient up here, and according to how big the radius is. Because if I change this value, -7 will mean something very different. I.e., if our radius is just 7, then 7 will be it will draw the eyes kind of like at the top of the egg head. But if the radius is massive, like 164, then -7 will be tiny, so the eyes will be close to the center of that bigger object. So scale is important. So basically, if you're drawing things like this, you want that 7 to be related to the radius. So I'm not going to do that here, but just keep that in mind. So I've lifted them up and I've lifted them apart, like a facelift, an egg facelift. How does Sue's look? That is still a little scary. we need to lift them up maybe a touch more. And I'll stop fiddling around now. Much further apart. 12. And we need them bigger. So the egg size, sorry, that should be eye size. Egg size, that's confusing. Eye size. I'm just correcting this terrible mistake. Sorry, there we go. Eye size. We've divided the now this is good. We're keeping the eye size relative to the radius. So this is what I meant. So we want it to be the radius divided by, we want them bigger. So a smaller number here. Maybe almost twice as big. Some bad maths there for you. That almost looked cute. Yes, it does look cute. You know what? I'm going to leave it. There we go. I've committed. Right, we've got our little Suze is being drawn. I forgot what we're doing at. Right, we need to get going. We need mouse interaction. We haven't even got physics. So we've drawn the egg. So we had a function ready. So do the physics. So we're going to do what's called Euler integration, which means we're going to add have we got speed? Yes, speed x plus equals, so that means plus itself and this amount. So we want, sorry, it's going to equal itself plus an amount. The amount is going to be the force, there we go, in the x direction. And we're going to say exactly the same for speed y, plus equals this force in the y direction. And then the next step of a basic physics engine is to add that speed now to its position. So this is kind of making sense, hopefully. The position is going to be changed by the speed, and your speed is changed by a force that's applied to you, which is acceleration, change of speed, acceleration. So, or rate of change of speed. So we've got this position, this x, plus equals this speed. So you'll notice I'm doing plus. So if speed is negative, it will go left. If speed is positive, it will go right. So it's a bit like a vector, really. Plus equals this speed y. Now, if you know about creating vectors in P5, I would do that. I've done separate x and y variables to keep things simple, although it makes coding it a bit more difficult. Anyway, so we've changed the speed by the force, we've changed the position by the speed, and the final step is to just make sure that we take our forces back to 0 so that we're ready to apply new forces next time the loop runs. That's how Euler integration usually works. There we go, in terms of physics. So we've got forces. Let's add the force of gravity in here. We should maybe make a new function to do that, but let's just do it. So we want this force, and of course we're going to add it to the y direction. Gravity works this way in 2D physics. So force, and we want to add, it wants to accumulate that force. I don't know, something like 0.1. Keep it very, very small. Okay, so we've got our force of gravity added, being applied to our egg. So if we run it, will the physics work? I'm expecting not, because we haven't told that physics, oh, I do love Suze, you're so cute. We haven't told the program to actually add it. So where do we do that? We need a draw loop. So P5 will a P5 sketch program will almost always have a draw function, which P5 just loops over and over and over again. So it's your game loop, your animation loop. So first thing we want to do is redraw the background, else we'll just get a trail behind Susie if she ever moves, if she ever becomes alive. Or I guess undead, because she is a ghost egg. So background. Took a lot of thought. Let's just copy a color from up here. So redrawn the background. Now we want to draw egg. So draw you, and we want to make sure that we're doing your physics. So Suze, could you please do your physics? There we go. So I'm not sure if I explained the dot here, but once you've got a variable that is storing an object, which is an object, to access the functions, to ask it to do things, you use a dot and then just write the function name. That's all there is to it. So that particular egg will now be drawn. So we could have another egg, and this will illustrate how objects are kind of working, and this dot, all that kind of thing will make sense. So let's call another egg Poppy. There, Poppy, and we're going to do the same thing. So Poppy equals a new ghost egg. So this is a different instance, and we're going to say we're going to put Poppy in a random place. So the math.random will return you a value between 0 and 1. Or including 0, I don't think it includes 1, so maybe 0.999, whatever, I think. So then we want to scale that. We don't want Poppy just to appear up here, a tiny value between 0 and 1. We want her to be able to go like across the whole screen. So it's between, like, if math random returns 0.5, that wants to be the middle of the screen. So 0.5 times the width will be the middle of the screen. If it's kind of like 1, if it returns 1 or close to 1, that'd be 1 times the width, which will be across the screen. So basically I'm scaling things up. That's how to use random. I hope my explanation, I wasn't too rambling. So we're going to scale that return value between 0 and 1 to the height for her y. Her y position. Because if you remember, when we ask for a new ghost egg, it takes an x and a y. So Poppy is a new ghost egg, and we're putting in an x, which is a random position across the screen, and a y, a random position down the screen. So we've got Poppy. Now we're not drawing Poppy yet, so we want to say Poppy, draw egg. There we go. Let's see if that works. We should have 2 eggs. One of them moving according to physics. Yes. Oh, beautiful physics. That worked quite well. So this is Poppy. She can float because we're not doing her physics. She's a non-physical object, which makes sense for a ghost egg. I just had an idea. I really want her to bounce according to some, according to a sine wave. Can I just add that in really quickly? I should be doing mouse interaction, but I want to do this. So ghost egg prototype bounce equals a function, and then I just want to say this y plus equals now we need like a distance that it can bob. Bob distance is going to be 14. 14 times now I want sine. I think I have to put math sine, and then we want a variable that increases. So we could use the P5 frame count. That would just take the frame count. Let's just see if that works. So we can have, well, that'd be nice. We could then have Poppy bouncing because she's got no physics. Let's see if that works. I've got a feeling she'll be bouncing very fast. So Poppy, that's ridiculous. So what's determining the speed of that? That's the frame count. I've lost bounce. Here we go. Bounce. Frame count divided by I don't know, 100. Does that slow it down? Again, notice that I'm doing a calculation in there. What on earth happened there? Divided by 10. I think 14 does not determine the amplitude of the wave. I clearly don't understand my own formula. Right. It looks really cute. Let's slow that down. 14, is that? Oh, what am I doing then? Will that be this? No, that will. I'll try 10. Sorry. I don't... Basic trigonometry is not working. Is beyond me. Let's try 72, and then I must stop. So that's far too big. So we need, oh, yeah, I only want this to be something like that. And then frame count, yeah, divided by 100. Yeah, that'd be better. Yeah. So, well, this should create quite a bit of a faster bounce. And it's not a big enough distance, so let's quadruple the distance. No, that should be anyway, that'll do. We've got a subtle bounce going on. Some embarrassing lack of knowledge for trigonometry, and our next step is to get some mouse interaction going. I really need to keep this video shorter. So what we want to say is, let's just bring up the program again. What we want to say is, when the mouse X or Y is basically less than its X position plus its radius, or the mouse Y is greater than its Y position minus its radius, or the mouse position is less than its Y position plus its radius. And if I'm then dragging the mouse or pressing the mouse, we want a force maybe we could add in the direction of the mouse, or we could simply say it's X, the ghost's X, the ghost X and Y equals the mouse X and Y. We could do that. For a physics engine, it's better to add a force. If you've got a physics engine, it's best not to simply move your object through like doing it. through hard variables, just instantly telling the x and y to go somewhere, unless you're doing teleporting or something like that. If you've got a physics engine, you get smoother movement and things, a much prettier simulation by adding a force. So we're not going to do that. We're just going, because I'm running out of time. I need to check. I need a function here. Let's say function mouse pressed. There we go. Function mouse pressed. Or let's have function mouse moved. So if the mouse is moving, is it move or mouse moved? Or try move. If the mouse is moving and we're over the egg, then we'll move it. So let's say this, if mouse x, so mouse x is p5's variable where it'll store the mouse x, mouse y is the corresponding one for the y axis. So if mouse x is greater than, let's just focus on Poppy. It's greater than Poppy's x minus Poppy's radius. Have we got radius x and a radius y, or just radius? We've got radius and radius y. So we'll remember radius y when we come to the y-axis. So if the mouse is more than the top of Poppy's head, and mouse x is less than Poppy's like bottom part. What am I doing? No, sorry, not talking about top and bottom. The left side of Poppy. This mouse is less than its right edge, Poppy's right edge. And then the mouse y is greater. Here's Poppy's top. Poppy y minus Poppy's radius y. And finally, if the mouse is less than Poppy's bottom, there it is, plus Poppy's radius in the y direction. There we go. Now, what we really want to do is, because we've got objects, we want this to happen for all of our egg objects. So let's put a stop to this. No, let's put a stop to this whole thing. Let's carry on as we were, and we'll at least get mouse interaction working, which was the whole point of this tutorial. So if the mouse is moving and it's over Poppy, then what do we want to do? We want to say Poppy's x equals the mouse x, and we want to say Poppy's y equals the mouse y. Yes, there we go. Also, if you use an if statement like this, and it's true, if it's true, then it will do the first thing, and it will do the second thing every time the mouse moves. So basically, we want to say only do these two things if it's true. If we had left the brackets off, every time the mouse moved, it would have at least done this instruction. Apologise, that was a little muddled, the explanation there. Hopefully that makes sense. Right. Mouse moved, yeah, that should be called. So before, sorry, I test this out. I'm sorry if this is really annoying. I just want to make sure that Sue stays on screen. So bounce, no, do the physics. We want to say, after everything is said and done, let's say this dot y equals, And then this p5 function, I think it's p5, not native to JavaScript. Constrain, we want to constrain this y between 0, that's the top of the screen, or let's say, I don't know, between 64 and height minus 64. So if this variable y has been changed and it's less than 64 or more than the height minus 64, then it will stay on the screen. It will stay at 64. 64 is the minimum that y can be changed, and height minus 64. So the screen height minus 64 will be the maximum value that y can be. So now, before we test out the mouse interaction, yes, our friend Suze will stay at the bottom. This is a bit bad. We should also, if that happens, cancel out the gravity force. So now gravity is building on poor old Suze. Mouse is moving, and we accidentally I moved over Suze, and now she's staying on me. Oh, if you move quick enough, you can get off Suze. There we go. What we really want is for this to happen when only when the mouse is pressed or the finger is tapping the screen. So mouse moved. I believe that will work for touch input as well. P5 is very good at identifying mouse interaction with tapping and touching automatically for you. So I believe if we have mouse dragged, that would mean only if we're moving the mouse and pressing down at the same time will Suze exhibit that behavior. And there we go. Mouse dragging, and Suze is now interacting with us, or we're interacting with Suze. Now we can't do it with, sorry, Poppy. This is Poppy, isn't it? I got my ghost eggs mixed up. Suze is affected by gravity, but not by this function, MouseDrag, because we're only referring to Poppy. So what we want to do is have an array of eggs and check both of them. We could copy and paste this, but then we're not really working with objects. We're just hard coding everything and pasting everything loads and loads of times. So what we really want is an array. So to create an array, I've definitely done this in the previous videos, so maybe I don't have to add this, but I'll try it very quickly. Variable eggs equals square brackets, so that's a variable, and we want to say, I have a for loop here. I'm not going to explain the for loop. Let's have 100 eggs. Let's not go crazy. 99 eggs. And every time that loops around, we're going to say eggs, and this is the index for each individual egg. No, I don't want to do that. I want to push a new egg into a particular index. So we want eggs push, and I want a new ghost egg. So this will look familiar. And let's just borrow Poppy's parameters. Because they will give us a random position on the screen. So now we're going to have 99 ghost eggs on the screen, and they're all going to be affected by gravity unless, oh actually they're not. In our draw loop, I'm not doing anything with them yet. So we need another for loop. We need to iterate, we need to loop through all the eggs. So all of the eggs is stored in this handy variable. You refer to your array name. Dot length will give you the number of objects you've got in that array, and we've just put 99 in there. So if we change this number now, that length will change dynamically. So that's how to avoid bugs. So if I had put 999 down here, I might have forgotten when I changed this number, and so on. So egg's length, and what do I want to do in this loop? I want to make sure I render my egg. So eggs, now I use this syntax. So that's referring to each egg object iteratively. So I is going to change from 0, 1, 2, 3, 4, 5, right up to the last egg. The last egg in our array, which is called eggs, not egg. It's a good idea to call your arrays, or pluralize, put an S on the end of your arrays. Helps you remember that it's an array, not just a singular variable. So eggs, what am I doing? Rendering it. Draw that egg, please, thank you. And then do I want to do its physics? Maybe half of them. So let's say if I is greater than eggs length divided by 2, then eggs do physics. Else you're going to be like Poppy and you're going to bounce. So eggs I bounce. There we go. Let's just see if we've got our eggs bouncing or gravitying. No, we've got a bug. So you can press, if you're on a Mac, Command Alt J using Chrome. That'll bring up the console. Or I think it's Control Shift J if you're on a PC to bring up the console when you're using Chrome. So the console handily tells you what line you've made a bug on. 25. Ghost is not defined. Did I put ghost instead of ghost egg? 25. A new ghost. You probably spotted that as I was typing it. There we go. Ghost egg. Sometimes, by the way, almost like a game, the most frustrating game in the world. When you've got a bug like that, maybe try and figure out what it is, go and change your code, look through it yourself, then go back. I don't know, for me, I like to do it as an exercise, just to practice. But I was trying to be fast there. So I don't know if that's scary or cute. So we've got a lot more ghosts. They don't seem to be bouncing or falling. So have I got... So I'm not going to follow my advice. I'm just going to go straight to the console. Egg is not defined. So I've written egg somewhere again instead of eggs. Why did that keep happening? Right, I thought it had just not frozen, sorry. It was just very slow. Again, that's very slow. Let's just follow my advice. Eggs length divided by 2. Do physics. Have I... Oh, I haven't opened my for loop. I haven't closed it. There we go. I must have been talking. Also, look at this. Disgusting stuff. Oh! There we go. It pays to be neat. It pays its way to be neat. Right. Let's run it again. So hopefully we'll have some gravity. This is third or fourth. Something even worse has happened now. Console. Unexpected token. Or maybe I'll put in too many brackets now. 61. Else. Oh! What? Why did I do that? I thought this was, sorry. I was doing something else there. Right. That does belong in the for loop. Oh my god, you must have been thinking, what is he doing? There we go. So we've got half of our eggs are falling down. I'm just going to take a screenshot. I think that took a screenshot. There we go. Because that looks kind of cool. Right. So we should only be able, where's she gone? We should only be able to move Poppy. So she was a bouncing one. Can I find Poppy? All the others not responding to the mouse being dragged, because the mouse drag function only references Poppy. So I can't find Poppy. So let's just now, when we're in mouse dragged, we want to do exactly the same thing, but iteratively. We want to, again, use a for loop to go through all of these. So I'm going to type this without speaking because I made about a million mistakes last time, and I'm still speaking. Okay, let's open the for loop, and then close it there, and then let's just put a space here, and then we want to replace all the poppies with eggs. So I think in brackets I can go to replace. Where is replace? Find replace, and I want to replace Poppy with eggs I. Hopefully that's just the poppies that I've highlighted there. Replace. Well, that's kind of nice. It doesn't replace them all automatically, but allows you to watch it happening. So now I can stop. There we go. So back to life, back to reality, back to mouse dragged. Yes, we are now iterating over all of the eggs, all of them, including Sue's. No, not including Sue's, because she's not in this array, neither is Poppy. So now they're going to be aloof of this happening. This is just going to attend to the eggs in the array. So hopefully, yeah, we can drag any one of these guys and they're going to move. The annoying thing is that, of course, they're all going to, and kind of collect them up, they're all going to attach themselves to the X and the Y position. So all we'd have to do now is add some collision detection so that the eggs can't overlap one another. So that's not really the topic of this video, so I'm going to quit while I'm ahead. There we go. Quit while I'm an egghead. Coming. We can't separate them. So there we go. We've got mouse interaction working, basic physics engine, and we've done it using objects and arrays, so we can quickly create lots of objects. I hope this was helpful, and it was inspired by someone's comment. Nop, I think that was your name. So thank you for your comment and your question. Nop, how do you get mouse interaction working? And I hope it's okay that I've used the P5 library to do it there. I think you said you were using jQuery. So thank you very much. I'm now going to stop the video. Here we go.